Welcome to KIF Chapter 5. We've gone out of order with our chapters, so that's why there's more chapters listed here than the chapters we've done. And yes, there's a bunch of erasing because I didn't realize I had pressed record until I got to number 3. Smooth move, Mr. Mo. Number 1, you make 24 equal payments for a go-kart. Racing around, you pay a total of $840. How much is each payment? Well, the total is $840. I'm making 24 equal payments, so how much is each? So another way of saying that is how much is one payment. In most cases, a 2-digit divisor, I'd round to the nearest 10. So for 24, I'd round it to 20. Or in this case, I have a good background knowledge of 25 because of quarters, so I can think of quarters instead. Now, can 1 quarter go into 8? No. Can 1 quarter go into 84? Yes, it can. I know it can go in there 3 times because that would get me to 75. 3 times 4 is 12. Carry my 1. 3 times 2 is 6 plus 1 is 7. Do my subtraction. 4 minus 2 is 2. 8 minus 7 is 1 is 12. My remainder, is it less than my divisor 24? Yes. So I'll cross off what I carried, and now I'll bring down my 0. Now we're thinking, how many times would 24 or 25 go into 120? I know 4 quarters equals $1, and then 5 quarters would be $1.25, which I recognize is close to $1.20. It's just a little bit too much, but I also know that 24 is just a little bit under 25. So maybe you'll be okay to guess 5 here. Plus, I have number sense, and I know that 5 times 4 would give me 20. That's going to line up my zeros. 5 times 2 is 10, plus 2 is 12, and there you have it, remainder of 0. So how much is each payment? Each payment would be $35 for that go-kart. Wear a helmet. Number 2, before a show, there are 8 people in a theater. 5 groups of 4 people enter, and then 3 groups of 2 people leave. Find how many people are now in the theater. Okay, so there was 8, and then 5 groups of 4 enter. So if they're entering, we're going to be adding, and it's a group. So 5 groups of 4, and I know of is another math term for multiply. And then 3 groups of 2 people leave. So if they're leaving, that's subtracting, and it's 3 groups of 2, and because it's a group, I'm putting it in parentheses. Okay? So how many people are in there? Well, I need to do my parentheses first. 5 times 4 is 20. And I can see my operation addition, subtraction will be fine, so I can actually do both parentheses at one time here. 3 times 2 is 6. Bring down the rest. And then I have addition, subtraction, so I can go left to right. 8 people are in there. 20 enter, so that puts us at 28. But then 6 people leave, so there are 22 people in the theater. Okay? Number 3, Mrs. Gillespie divides 36 students, so it's a big class, or maybe 2 classes combined, into equal groups for a scavenger hunt. Each group should have at least 4 students, but no more than 8 students. So at least 4 and no more than 8. So I know possibilities could be 4, 5, 6, 7, and 8. What are all the possible group sizes? So I'm asking myself, there's 36 students. Is 36 divisible with 4? Can I do 36 divided by 4? Yes, I could. There would be 36 divided by 4 equals 9. 9 groups of 4. Is 36 divisible with 5? No. So there cannot be a group of 5 students. How about, can there be a group of 6 students? 36 divided by 6? Yes, that is divisible. And actually 36 divided by 6 equals 6. So there would be 6 groups of 6. Is 36 divisible with 7? Okay, so 7 times what equals 36? I can't think of anything. It is not divisible. And then can I do 36 divided by 8? No, it is not. So the 2 possible group sizes are groups of 4 or groups of 6. Chapter 2. The cooking time for a ham is 2/5 of an hour for each pound. How long should you cook a ham that weighs 12 3/4 pounds? Okay, so 2/5 of an hour for each pound, but there's 12 3/4 pounds, so we have 2/5 times 12 3/4. But because I have a mixed number, I know I need to convert it to an improper fraction. I'm going to multiply, add, keep. Multiply the denominator and the whole number is 48, plus my numerator is 51. Keep my denominator, 51/4. 2/5. Now I could multiply across, but I'm going to try to make it easier for myself. I'm going to try to hit that easy button and look for reduction here. So 2 and 4 are a common factor of 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And then do 5 and 51 share a common factor? No, they do not, because it doesn't end in a 0 or a 5. So 1 times 51 is 51. 5 times 2 is 10. My answer is improper, so if I convert that, I know that 10 goes into 51 5 times. That would be 50, but because it's 51, I know I'd have a remainder of 1. And I keep my denominator. So, how long should you cook a ham that weighs 12 3/4 of a pound? You need to cook it 5 1/10 hours. So, hopefully, you're not in a hurry. Number 5, brr, it's been cold outside and Mr. Munir's in the mood for some chili. Make it spicy. 1 serving of chili is 1 2/3 cups. The restaurant cook makes 50 cups of chili. Is there enough to serve 35 people? And then explain. Okay, well, there's 50 cups, and then we're dividing it by 1 2/3 because that's how much it is for 1 serving. So we're trying to see if 1 2/3, how many times that can fit into 50, and then if that will be enough for 50 people. Well, 50 is a whole number, so I want to make that an improper fraction, so I can put it over 1. But then I see a mixed number here, so I actually want to convert that too. So really, we have 50 over 1 divided by, multiply my denominator, my whole number is 3, add the numerators 5, and keep the denominator. So I have the problem 50 firsts divided by 5/3, but I know when I divide fractions, I need to keep it, change it, flip it, or keep, switch, flip. And I believe numerically, I think you may have another phrase for that. But we have 50 over 1. I can change it now, change the division to multiplication, or multiply by the reciprocal, and the reciprocal of 5/3 is 3/5. I could multiply across, but I want to make it easier for myself, looking for common factors. 1 and 3, well, 1 is already as low as it can go, so how about 5 and 50? They both share a common factor of 5. 5 divided by 5 is 1. 50 divided by 5 is 10. So now I'm ready to multiply. 10 times 3 equals 30. 1 times 1 equals 1. So how many servings can there be? 30 divided by 1 equals 30. Is there enough to serve 35 people? No. There is only enough for 30 people. And that's if each person is only having 1 serving. I may be tempted to have 2. Number 6. Looks like we are, excuse me, order of operation problem because I see multiplication and I see subtraction. Well, following PEMDAS, I know I'm going to multiply first. Okay, so 1.046 times 5, I can just multiply. I don't have to worry about the decimals yet. 5 times 6 is 30. 5 times 4 is 20, plus 3 is 23. 5 times 0 is 0, plus 2 is 2. 5 times 1 is 5. But we have 1, 2, 3 decimal places, so I need 1, 2, 3 decimal places. And then 5.230 minus 0.88. Well, now that I'm adding and subtracting, I need to line up my decimals. So minus 0 and 88 hundredths. Because I'm lined up here, I could have a placeholder 0. 0 minus 0 equals 0. 3 minus 8, I cannot do that, so borrow. 13 minus 8 equals 5. 1 minus 8, I can't do that, so I need to borrow. 11 minus 8 equals 3. Here's my decimal. Bring down my decimal. 4 minus 0 is 4. So the value would be 4.35 or 35 hundredths. And then it's okay to have the 0 on the end, but they are the same value. 35 hundredths is the same as 350 thousandths. Number 7, some people get confused because they always think the one with the most digits is the dividend. That's not the case. It's always the dividend divided by the divisor. The dividend goes in the house. Divisor goes outside the house. When we divide it by a decimal, we need to make sure it's a whole number, so I need to move it 1, 2, 3 times to the right. However many times we move it in the divisor, we need to mimic that in the dividend. 1, 2, so I need to add a placeholder 0, 3. So 3 in the divisor, 3 in the dividend. And then I can bring my decimal up because I don't want to forget that. Now, does 3 go into 0? No, it doesn't. Does 3 go into 1? No, it doesn't. So how many times is 3 going to 18? 3 goes in 18 6 times, and since I'm looking at 18, I'm making sure to put it above the 8. 6 times 3 is 18. Subtraction, 0 is good. Bring down my 0. Now, don't be done, because there's a big difference between saying the answer is 6 or how many times is 3 going to 0. And that is 0. 0 times 3 is 0. There's nothing left. Big difference between 6 and 60 is our quotient. Okay? So that's it for side 1. Side 2, identify the terms, coefficients, constants in each expression. Terms are the number of parts. Okay, so to not be confused, this is saying number 8. Terms are usually separated by an operation sign, such as addition and subtraction. Okay, so I see addition, so I see 3 parts, so they are 15, 3W, and 1/2 are the 3 parts or terms. Coefficients are the co-workers with the variables. Every variable has a coefficient working with it. So I see the variable W. Who's working with the W? The 3. Coefficient goes out in front. And then the constants are those that don't have a variable. So 15, no variable, so 15 is a constant. 3W, variable, so it's not. And I have 1/2, there's no variable, so 1/2 is a constant. And yes, constants can be fractions, mixed numbers, decimals. Doesn't matter as long as there's no variable. Looking at number 9, terms, how many parts do we see? Well, there's an addition sign, so I see 2 parts. 5C squared, so it's a big term, and also 7D. Coefficient, every variable has a coefficient. I see C. Now some students mistakenly say the exponent is a coefficient. No, the coefficient goes in front of the variable. So what's in front of C? That is 5. And then I see the variable D. Who's working with D? The 7 is the co-worker, the coefficient. Constants. Variable, variable. There's nothing without a variable, so there are no constants. I'm not going to put 0 there because some expressions might have plus 0 or something weird like that. So we can just go ahead and put a slash or leave that blank. We don't want to acknowledge 0 as a constant. Write the phrase as an expression, not an inequality. Then evaluate when x equals 5 and y equals 20. Okay, so the sum of a number x and 4 all divided by 3. So the sum of a number x and 4, well that means I'm going to be adding those two. X and 4 would be x plus 4. And all that, okay, is divided by 3. And I'm going to choose to use the fraction bar here, divided by 3. Okay, now I can evaluate, I can substitute. Looks like I have the variable x is 5. So if I substituted a 5 in there for x, I'd be making sure to do the numerator first. 5 plus 4 equals 9. And then I can do my division. 9 divided by 3 equals 3. 3 is the value. Number 11. The quotient of 40 and the difference of a number y and 16. So I can kind of see how and the difference of a number y and 16. The y and 16 go together as kind of a grouping there. And since it's the quotient, I know I'm dividing those as well. So 40 divided by the difference of a number y and 16. So the difference is telling me we're subtracting y and 16. And now I can substitute. It says y equals 20. So if I had 20 in there for y, I know there's nothing to do with the numerator, so that would stay the same. And then 20 minus 16 equals 4. And then 40 divided by 4 equals 10. The value is 10. And number 12. Mr. Petrov and Mrs. DePau would both like to display the flag below in the room. How much area would they need on their wall to hang this flag? Okay. So it's a large flag, and there's a lot of dimensions here, and there's a lot of different ways I think we could cut this up, because I'm seeing triangle, I'm seeing a triangle here, I'm seeing a larger triangle here, and then if you wanted to, I could see a trapezoid there. Okay, a lot of different possibilities. I also see the top is the same as the bottom, so if I were to cut this in half, I knew if I found either the top or the bottom, well then I could just times it by 2 to find the area. Now if I'm looking down here at the bottom, I know there's a lot of dimensions in here, but I see that there's one set of parallel sides. This bottom side is parallel with this right here. Okay, so I know the quadrilateral with one set of parallel sides is a trapezoid. And I remember, and there's a couple different ways to do the formula area of a trapezoid at half the height times base sub 1 plus base sub 2. is one that I'll be using here. Okay, so now it's just substituting in. Come on, coach, blow the whistle, make a substitution. We're trying to find the area. We have 1/2. Now, what is the height of this trapezoid? Okay, just to make sure we're on the same page. And actually, it doesn't tell us the height of this over here. This is the entire length of 30, but I know I could cut that in half. Or if you're looking around and paying attention, these two lines are 15, so I know the height is 15. Now base sub 1, I see is 60, plus base sub 2 has a length of 44, except we can't be putting in 44 because we're going this entire length, so we need to do 44 plus 8. Now I know that 44 plus 8 is 52. Do my parentheses first. 60 plus 52 equals 112. So I know area equals 1/2 of 15 times 112. Okay, I usually like to make it a little bit easier, so I'm going to take half of the larger number, especially since it's even. Okay, so what's half of 112? So if I divide that in half, I know that half of 112 equals 56. So half of 112 equals 56. And then I know I'd still need to do 15 times 56 to find the area. So 56 times 15. 5 times 6 is 30. 5 times 5 is 25. Plus 3 is 28. Bring down my 0. 1 times 6. 1 times 5. 0. 14. 8. Partial products add up to 840. So I know this part of the flag, the area is 840, but I know I'm going to have to do that times 2 to be the total area. 2 times 0 is 0, 2 times 4 is 8, 2 times 8 is 16. So the area equals 1,680 inches squared. So Mr. Petrov, Mr. DePau, hopefully you have that much room on your wall. So there's part 1 to KIF, Keeping It Fresh, Chapter 5.